This really is just a list of answers. We can discuss specifics or questions here in a few minutes. Please do give yourself a score out of 4. Please just mark them right or wrong. Just treat this like a quiz. And I do want you to kind of compare to yesterday. The hope is that you stayed the same or got better from yesterday. Hopefully if yesterday you made 2 out of 4, today you made 2, 3, or 4 out of 4, right? We want to see a pattern of improvement. We don't want to see the same thing over and over again or getting worse. We want to see improvement. So I don't want you to think about it. I want you to literally on your paper, I want you to write some score out of 4, right? 2 out of 4, 3 out of 4, whatever it is. When you get done grading, give yourself a score out of 4. Okay, so now would be an opportunity for you to ask questions. Go ahead, Sebastian. Number 3, happy to. Okay, so number 3 asks us to find the equation of a line that is perpendicular to this other line. And so kind of like yesterday, I would say that perpendicular is a key idea here. There we go. And not only that, Sebastian, I would just ask you that same old question that I asked over and over and over and over again. If you're trying to write the graph or an equation of a line, what are the 2 things you got to have?
The slope.
And isn't the point pretty much gifted to you?
Yep.
I mean, the point is right here. And so I'm going to, because you're looking for a point and a slope, I'm going to go ahead and use point and slope form. So Sebastian, what I would suggest is right away, I could write y minus 7 equals blank times x minus negative 8. I know I can do this because I know that my line goes through that point, and the only thing I really need to do to put some work into this is I got to figure out what the slope is. That makes sense so far?
Yeah.
Okay. So then I'm told that my line is perpendicular to this other line. I'll highlight the other line in red. My line is perpendicular to that one. So the big question here would be, what's the relationship between perpendicular lines? You know what it is? What's opposite? Opposite and reciprocal, the what?
Y-intercept?
Not the y-intercept. It's a slope, right?
The slope.
The slopes are opposite and reciprocal. So what's the slope of that red line? It's 4, isn't it? So what's the slope of my line? Yeah, you got to flip it to be 1/4 and then do the opposite so you get negative 1/4. So I'm going to put that right here as my slope. Does that make sense? So then it does ask for this answer in slope-intercept form. So what would be my first step to get this to slope-intercept form?
Y by itself.
Yep. Maybe a distributive property. Maybe add 7. Either way, you can do it. I'll do the distributive property first. So it'd be y minus 7 equals negative 1/4 x minus 2, right?
Mm-hmm.
Negative 1/4 times a positive 8. 1/4 of 8 is 2, right? And a negative times a positive is a negative. Then my last step would be to add 7 to both sides to get what you said, to get the y by itself. So it'd be y equals negative 1/4 x. There's your plus 5. What do you think?
Yeah, that's
Follow-ups on that one, or maybe a different question? Treat this like a quiz. You know when you look in the grade book and you see, oh man, I got 1 out of 4? Darn it, I'm frustrated. Like if you got 1 out of 4 right here, you should feel the same way. But the good news is you still have time to get better. Right now and tomorrow. Yeah, Mason.
you number 1.
Uh-huh. So number 1 says evaluate.
Sorry, number 2.
Number 2?
Yeah.
Sure. Number 2 says graph the following. There are a number of ways to graph this. I think that slope-intercept is a good way to do it. So that linear equation is currently not in slope-intercept form. What would I need to do to get that into slope-intercept form?
Like 3y, and then
I don't think I want to subtract 3y because I want to get the y by itself. I want to start getting things away from the y.
just add 5x.
Adding 5x makes a lot of sense because that'll start to get that y a little bit more by itself. So that would give me 3y equals 5x plus 6. What would be my next step to get to slope-intercept form?
Divide by 3.
Got it. So divide both sides by 3. Y equals 5/3 x plus 2. Once I've gotten there, I'd want to identify that this is telling me that my y-intercept is 0, 2. And this is my slope. So like I said earlier, the way that you write the equation of a line or graph a line is you need a point and a slope, and I've got both of those. So Mason, which one do I graph first? Do I graph the slope first? Do I graph the point first? Say again?
The point?
Yeah, so 0, 2 is right here. And then I'll count off my slope. It's rise over run.
Yep.
So I would go up 5, 1, 2, 3, 4, 5, right, 1, 2, 3. And I could go backwards 2, down 1, 2, 3, 4, 5, left 1, 2, 3. You can see that it follows that nice linear pattern. I connect those points with a straight line as best I can. And there you go.
Yep.
Somewhere in there it clicked, right? I can see it. Okay. Anybody else? Question, follow up on that one? Anybody want to see number 1 done? Okay. Number 1. So number 1 is an order of operations. Can I just give you a big hint about order of operations? It's never super easy. Never at any point in your math career, and when I say yours, I mean mine too. Like when I do a question like number 1, I usually follow order of operations because I don't want to get it wrong, right? I take my time. It's never just like this total turn your mind off thing. It's always going to be a challenge. So PEMDAS is the little acronym telling us that we need to do any work inside the parentheses first, and there's a lot of work, right? There's a 6 times a 2. There's a 9 in there. There's a lot going on in the parentheses. So I would write this first. 7 minus 15 divided by 5 plus, we might be able to do a couple of steps in our head, right? 6 times 2 is 12. And what's 9 minus 12? Negative 3. Okay. So at this point, if I might do that in 2 steps perhaps, especially if it's a little more complicated in there. But I've done all the work in the parentheses, right? After I've done the P in PEMDAS, what does the E stand for?
Exponents.
So I do some exponents next. There's one exponent. This is easy to get tripped up on. What's negative 5, or not negative 5, negative 3 inside the parentheses squared? It's plus 9, right? Ellie, what do you think about the plus positive 9 there? You okay with that?
Yeah.
Sometimes people think that it should be negative 9, but it's positive 9. Okay. Once I've done the P and the E, it's down to multiplication and division. I see a division, so I'll do that. 15 divided by 5 is 3. And once I've handled that, I see that the only things left to do are addition and subtraction. So I'll just go from left to right and cover those additions and subtractions. 7 minus 3 is 4. 4 plus 9, there's your 13. Okay, so as always, that all sounds great in my head. Might not sound great in yours. Be happy to follow up or whatever if you have any other questions or if something doesn't make sense. Keep in mind, math is supposed to make sense. So if it doesn't, pursue it until it does make sense, right? That's really the heart of math, trying to get you to pursue that logic, pursue it making sense until it does. Any questions? Okay, well, speaking of making sense, we're going to continue to practice what we did yesterday. And I think I'm going to send you all, one person from each table. Your mission is to grab a little whiteboard and bring whiteboards back for your table. I want to kind of test and see where you're at from yesterday, and then we'll continue to push forward and practice. So grab a little whiteboard and a marker. Just send one person from your table to grab a little whiteboard. We'll get markers in everybody's hands, and we'll do a little bit of practicing from yesterday. Okay, if y'all would, please take a look at that first one up there, this little review from yesterday. Please do your best. So Sasha, we're not on that one right now. I want you guys to try this one right here. We'll come back around to that one. That was definitely not wasted effort. Well, the microphone was, the checkerboard was, but you guys would please try to solve this equation. Just flip your whiteboard once you think you have it. So remember before, so Mason, I want to help you. Before you square root both sides, you need to get the squared quantity by itself. So I'm looking over there on Anya's board, that first step of -4 makes a lot of sense. She's trying to get the squared quantity by itself. We don't just jump in and start squaring things because it ends up not making sense. So again, once you think you have an answer, just flip your board, and I'll let you know. Chase, that's correct. Close but not quite, close but not quite, close but not quite. That's correct. Good job. That's correct. Not quite. You lost your squared. You actually, you know what? You never had your squared. It's 7x squared. Close but not quite. That is correct. That is now correct. There you go. That is correct, Sasha. Well done. So it should be plus or minus that. Close but not quite, close but not quite. That is correct. That is confusing. It looks like plus equals.
Plus or minus.
Now it makes sense. Plus or minus. Yeah, you got it. 3, that's right. Yep, you got it, Issa. Good job. What's the square root of 4?
2, Sasha.
All right, we got it. We got it. There you go, Kate. So, Oliver, you good? You got everything else right? Okay, so for those that maybe are just finishing up, here's what the steps ought to look like. We want to get the squared quantity by itself first. So I'd subtract 4. Please check this out. This is for your benefit, also for the video. Dividing by 7, you get x squared equals 4. Please watch. Some of you weren't quite there yet at the end. This is where I square root both sides. So I get x equals what? You got to consider both the positive or the negative square root there. Yes, ma'am? You don't get it? Like why? Good question. Okay, so, hey, listen please. Listen. Word solve means a lot of things, right? It means get the x by itself. Here's another version of what solve means, and this really gets to the heart of what you're asking. Solve means find numbers that work in the equation. Right, so find numbers that work for x. So when I get to, you can see it, you can really see it at any stage, but I think the clearest spot is, guys that are just chatting over there, please stop. It's a distraction to me. So when you get to this stage right here, x squared equals 4. And obviously, you subtracted 4 divided by 7 to get here. But you get here, x squared equals 4. And basically, this is asking this question. And this kind of goes back to the Desmos we did yesterday. You're saying, what number squared is 4? And I don't know if you remember from the Desmos yesterday, but a lot of people said, well, you know what? I just plugged some numbers in and they worked. Remember that? So check this out. If I did 2 squared equals 4, well, gosh, that's true, isn't it? If I tried negative 2 squared equals 4, well, that checks also. There are 2 different answers. A positive version and a negative version of that square root give solutions for this equation. There are some deeper reasonings. Do you want to see the deeper reasonings or not?
Yes.
This might mess you up. So I'm running the risk of messing you up, just being straightforward with this. So me teaching you the plus or minus, your book teaching you the plus or minus, is a shortcut for this. The square root of x squared is actually not just x. It's actually this. It's the absolute value of x. And if the absolute value of x equals 2, aren't there 2 different numbers that have an absolute value of 2? Positive 2 and negative 2. That's really what it is if you want to get down to the details of it. Yeah. Okay. I'd like a little bit of Golly. You know, I think I've had about all the feedback I need from you guys. You guys did really well with that. The only mistakes I really saw were forgetting a plus or minus here or there. And Ellie, you just asked a good question about it, so hopefully that helped everybody. I think I'm ready to kind of jump into the ones that we finished with yesterday. And this would be my goal. I hope that you'll share this goal, that by the end of our class today, that you would be good and solid and have close to mastered questions like number 1. So we did this yesterday. What I think I want to do with this is have you guys kind of tell me what you think the steps ought to be. And we'll make sure that we have the ideas and the concepts right. And then I'll start trying to see if you guys can practice this on your own, right? So does anybody, now listen carefully. You guys might have really good suggestions. You might have bad suggestions. Let's find out. Does anybody have a suggestion on what I would need to do here first? Ray, go ahead.
Give the 7 over to the other side.
And I would do that by doing what?
Subtract.
So Bray has identified a logical good first step. Subtracting 7 makes perfect sense. So that's what I'm going to do. It's number 1 in your packet. So, hey guys, remember again here in a couple minutes, we're going to see if you can do this by yourselves, or at least close, right? So subtracting 7 makes sense. So when I do that, I get 6 times 5a minus 2 squared equals 24. Remember, we're trying to get the squared quantity by itself here. Does anybody have a suggestion for maybe a second logical thought? Chase, what do you think? Dividing by 6. That would get the squared quantity by itself. So if I divide by 6...
Multiply, like you just distributed it.
okay, you want to talk about that?
Yeah.
So if we did that, remember the idea here, like I so much want you guys to separate yourselves from the idea of my teacher told me the steps, so I follow the steps. I want you to think about, is this logical? Does this actually make sense? And so let's explore what you just suggested there, Mason, because a lot of people do feel like this is important to do. So what Mason suggested is maybe we should distribute the 6 like this, right? And I don't know what happens with the squared when you do that, but can anybody identify the flaw in that logic? Can anybody identify why that doesn't work? Why can't I distribute? It's not correct. It doesn't work. Nobody knows? Well then, Bray, I got to say this is my favorite comment of the day so far because no one seems to know why this is wrong. Let's talk about it. If I'm going to distribute it... Oh, yeah, Bray, go ahead.
Well, because the 6 has to go over to the other side for it to equal 4.
Well, ultimately, that is the right idea. I totally agree. But what Mason is suggesting is maybe we could do a distributive property instead. Maybe that would be just as good and it would all hash out in the end. So I think on a couple of levels, please pay attention because what Mason brought up is, like I said, is what a lot of students are tempted to do. If I am going to be doing a distributive property, that's really a simplification idea. And with simplification, I've got to follow PEMDAS. And isn't distributive property just multiplication? So if I were to distribute right here, aren't I doing the multiplication before I do the exponent? So if you are really fixed on, no, I'm going to do a distributive property, do you know what you have to do before you do the distributive property? You're going to have to square that quantity. You're going to have to do a 2 by 2 box with 5a minus 2 with that binomial, and you're going to have to square everything. It's possible to do it that way. You'd end up having to do something called complete the square. It's going to make a big, awful mess. Don't do it. It just goes out of order of operations. And even though it's mathematically possible to do it, it just makes more work for you. And believe me, I want you to do well. I don't want you to do more work. Mason, does that help?
Yeah.
Okay. So, can you guys see how the squared quantity is now by itself? I can see that some of you have worked ahead. Once the squared quantity is by itself, what do? I'll say it again. Once the squared quantity is by itself, what do? You square root both sides. So we square root this side, we square root that side. This gives me 5a minus 2 equals
2 plus or negative 2.
plus or negative, plus or minus 2. The plus or minus has to be in there right now. Okay, so our final goal is to get the a by itself. Some of you worked ahead of me. See how you did. If I'm going to try to get the a by itself, what would be my next step after I did this whole plus or minus thing? Go ahead.
Add the 2 to the other side.
That's right. So I'm going to go plus 2 on both sides. This is where you're going to be tempted to do some really crazy things. Don't. Plus or minus 2 is 2 different numbers. I would suggest you write it like this. 5a equals 2 plus or minus 2.
Wait,
I know you want to write plus or minus 4, don't you?
wouldn't that make sense then?
No, plus or minus 2 is 2 different numbers. Maybe, you know what?
Oh, because it's just a plus to the side.
Maybe I'll show you. I normally wouldn't show you this until the end. But what this really is 5a minus 2 equals 2, or 5a minus 2 equals negative 2. It's two separate equations, to be honest with you. This might be better for you. I don't know. Let me go plus 2 over here. You can see how this develops. So this would give me 5a equals 4. This would give me 5a equals 0, wouldn't it? What would be my final steps here? I'm over here right now. Oops. If I want to get the a by itself, what do I do?
Divide by 5.
Yep. So divide by 5. I get a equals 4/5 or a equals 0. How would that look over here? Well, on the left side, if I was going to do this idea, wouldn't I divide by 5 as well? I asked you a question. Does it make sense?
Yeah.
Okay. Again, we're going for logic. We're not going for my teacher told me. Going for logic. So I'm going to come over here and try to finish. So I get a equals 2 plus or minus 2 over 5. I could split it up here. This means a equals 2 plus 2 over 5. Or a equals 2 minus 2 over 5. Can you see how we're going to get the same answers? 2 plus 2 is 4. So it'd be 4/5. 2 minus 2 is 0. 0 divided by 5 is 0. So whether I split that plus or minus up really early or I split it up late, I will be getting the same answers. Okay. How y'all doing? Okay, so you got part of the way through. I don't know, writing it down probably makes a pretty big difference for you. I don't know, we'll see. Why don't you guys move on and try number 2 out of your packet. Again, our goal here is just to see if we can get you guys to master this, or very close at least by the end. Yes, sir. Question, yeah.
No, I see where it came from. I was just going to ask about the 0, but I see where it came from.
Basically 0 divided by 5 came from 2 minus 2 divided by 5. You sure you're good?
Yeah.
Okay. So let's try your next effort at number 2. This one should not involve a calculator. Not going for a decimal answer here. Going for, it says simplify completely. So 63, notice it says simplify completely. Square 63 is a radical, right?
That's fine. Right, that's the
Remember how we simplified radicals with like the prime factors and factor trees and all that stuff? Go there. So that is totally correct. Just simplify the root 63. You have everything else in a good place there. Idea? Keep going with that.
Well, it does say simplify completely.
So square root 62 is obviously not a perfect square. It says simplify completely. Do you guys remember how we simplified those square roots with the factor tree and the pairs of like factors and all that? That's what you need to do with simplify. What did you get? That's correct. That's not correct. You're just not done. I wouldn't erase anything. I would just simplify 63 go to 2 on 9 and
Mr. Anderson.
So you would get really close. Remember when you square root both sides, it's just plus or minus. You should do that. Right away. close, you just lost the plus or minus, or you never had the plus or minus. Remember, when you square root both sides, then you have a plus or minus on that square root.
Plus or minus 3. There we go.
No, it'd be negative 3.
Negative 3.
I'm pointing at this thing. This 3 is negative 3. No.
Is that right?
The way you have it written is not correct. What did you square root? Didn't you square root this?
Yeah, but that is.
So to be honest with you,
It's like I didn't.
when you square root both sides, the plus or minus should be right there, right now. Should be right there, right now. And therefore, it should be right there. Well, in front of this whole thing.
Wait, Mr. Anderson, so is this
Because 3 root 7 is root 63. They're the same thing, so that plus or minus would just be hanging out front the whole time. Yep,
Hey, Mason.
that's correct. Yeah, you were trying to add unlike terms. You were trying to like
Oh,
combine those
yeah,
two
I
terms.
was.
And they're not
I
like
was
terms.
so
That's right.
I forgot about like radicals.
Like radicals, like terms. Yep, exactly. How are we doing? You get the plus and minus. How are we doing, guys?
And you get a, here, look.
Okay, so.
I actually understand it for once.
Square
All the other ones
both
are like,
sides here. The plus or minus actually goes on this.
This actually gets
So this should be here, therefore this should be here. And then you want to simplify your root 63. Remember back in unit 4 how we took a radical like that and we did the prime factors?
Yeah.
Which was pairs of like factors? That'd be kind of your final step. You get it? Mushroom test 2020.
Hey,
No, I think it's mostly mushroom test. And butterflies don't butterflies. That's good work.
yeah?
No, because you said, right? You can compare yours to mine now, if you want. Hey, let me just, hey guys, spray over here, please. Let's just try to cement this even more in your minds. I'm encouraged. I'm seeing a lot of good steps. I think just about everybody I saw added 5 to both sides. That was definitely the right move because we're trying to get that squared quantity by itself. That gets you here. Now there's some timing issues. Trevor, there's some timing issues you all need to work out. You need to do this right. Isn't it time right now for me to square root both sides? What should happen immediately after I square root both sides? What symbol should show up? It should show up right away, not at the very end. It should show up right now. So it'd be x plus 3 equals plus or minus square root of 63. Right? Because you're saying, hey, the square root of 63, square root of 63, negative square root of 63, square root of 63. It needs to show up right now, not later, not at the end. It should show up right now. Last couple of steps would be to subtract the 3 over. I typically write it like this. Negative 3 plus or minus root 63. I think it's pretty standard to write the radical second, although if you wrote it in the reverse order, that's fine. Hey guys, please don't be a distraction. Last step here would be to simplify your radical, and using your prime factors, this simplifies as 3 root 7. So you get negative 3 plus minus 3 root 7. So already I can tell you're doing better than yesterday. I don't think we have this 100% completely mastered yet. So let's do another example or two. Check out number 3. No, I don't like that one. Do number 4. Sorry, do number 4. We'll talk about number 3 together. We'll finish with 3. Please do number 4. Please do number 4. Put the mushrooms on hold. Do number 4. Sure. She's trying mushrooms. You're going to find number 4 is really similar to number 2. Just like the one we did. Different numbers, obviously. This will be a good kind of a final check to see how you're doing. Good first steps, for sure. right here. So going from here to here, you clearly were trying to square root both sides. And that's definitely right in all these steps of grades. If you square root this side, doesn't the square root of the square cancel out? Does that make sense? So if the square root and the square cancel out, I don't think the square root should be there anymore. Does that make sense?
What'd you get?
It is. Keep going. Yep. What'd you get? 0 issues with that. That's good.
X equals plus or minus two.
Yep, you'll have a little factory to do. All right, this is good news.
I got 38 thirds. 12.
It is true, right? Yes.
Mr. Anderson, is this like the red box or?
What do we got? Yeah, that's definitely correct. My only piece of advice is as you move through up to like other math classes like Algebra 2 or something in college, or whatever it is you end up doing, typically they're gonna write the 5 first and the radical second.
Okay, so
I'm not gonna be terribly picky with that as long as it's the right
so
answer.
where you've written plus or minus 2.
Yep. Should definitely be. Still same thing, correct? Totally correct. This is numerically correct. I'm just saying you might get some teacher in the future that's really picky and say, you need to write it this order. I just want to know that that's
I actually understand it.
Good. Okay, Sydney, that is correct. This is backwards. It should be 2 root 3 instead of 3 root 2. Yes, that is correct. That is also correct. Okay, so you put the 5 inside the radical.
Mason actually understands the concept.
Oh.
Mason's like, I actually get this one.
Plus 5. Because like when you get to here, like when you get here where you have 5 over, the 5 is not a radical. So you really can't combine them.
I was confused by outlines.
And so yeah, for that reason, so it's interesting. Yes, that's correct. I'm gonna suggest that you guys write them in a different order than that. I'll show you that on screen. I would suggest you write like a radical expression second. Sorry. Question.
Is this the right answer?
That's the right answer. Good job. Yeah, interesting question. We're going to come around to that. Don't erase that. Don't erase that. Hey, I'm not going to answer that yet. Hey, guys. Hey, listen up. I'm going to run through number 4 really quick, and we'll finish off with number 5. I want to just tell you, I hope that you trust that I'm honest with you. Like, sometimes I tell you that you're not doing that great. I want to tell you right now, I think you're doing great. I feel like if I gave you a pop quiz on this right now, the vast majority of you would get it correct. It's a good place to be right now. So let me just show you this real quick. Let's just reinforce. Make sure you are doing the right steps and thinking the right things. You need to add 7 to both sides as a good first step. Saw just about everybody do that. And then I saw just about everybody say, you know what, I need to divide by 3 on both sides. That is also a very logical, good step. X minus 5 squared equals 12. This is where people square root of both sides. Again, logical, good move. And you guys improved a lot on the plus or minus. That was also a really good move. So x minus 5 equals plus or minus root 12. And then I saw a lot of people that were trying and mostly very successful simplifying that radical. X minus 5 equals plus or minus 2 root 3. What's my very last step? Add 5. So I go plus 5. Now I saw a lot of people write their answer like this, and this is 100% correct. There's nothing wrong with that answer, but I think you'll find as you move on to like Algebra 2 or Geometry or Pre-Calculus or whatever it ends up being for you, you're going to find that your teachers, man, I hope you'll pay attention. I'm just trying to give you advice right now. I think you'll find a lot of your teachers want you to write it in that order. Both of these boxes are correct values. There's nothing wrong with either of those. but most folks later on are going to prefer the lower box instead of the upper box. So if you can start to build that habit in, it's a good thing. Okay, we're going to end our day with a little bit of a mind twister, which is number 3. Would you guys please look at number 3? Go back to number 3. And I want to go back to what we do with this doesn't work if you're chatting. I want to go back to like what we did with number 1. I want to do a little bit of back and forth where you suggest the idea. We should do this, we should do that. What do you guys think would be a good first step? Mason?
Subtract 13.
I think subtracting 13 is a fine idea.
It's a dozen.
3y squared equals -9. Who wants to add on to Mason's idea with another logical step? What should we do after this? Dividing by 3. This is where this one gets just a tad weird. We get here. What would be the next logical step? Square root. Does anybody see an issue with this? Has anybody ever encountered this before? Sophia?
There's a negative inside of the square root.
There's a negative inside the square root, and what's the problem with that?
Because it's still plus 1 minus.
Now, the plus or minus is not a big deal, right? Because we're just saying the positive square root or the negative square root. The issue is the fact that the number inside the radical, which is called the radicand, is negative. And let's explore why that's an issue. And let's use some easier numbers. Hey, Mason. Hey, Mason. Don't. Oh my goodness! I wish you wouldn't have erased it. It was really good. It was really good. Mason got here. That was awesome. Let's talk about why this is weird. I want you to see some, maybe some easier numbers to help you understand why this is a really awkward situation. If I asked you to do the square root of positive 25, what do you think the answer to this is? 5. This is absolutely 5. What if I asked you to do this? This is what Sophia pointed out. She said, wait a minute, it's a negative number in there. What do you think the answer to that is?
Negative 5.
So let's think this over. If you think this is negative 5, shouldn't I be able to check this by doing negative 5 squared?
Yeah, that sounds right.
Negative 5 squared is 25. So that didn't match. So then do you have any other ideas? Like what?
Is it just negative? Is it like plus or minus 5?
No?
It would be negative 5.
Guys, I don't know why you're packing up. You still got plenty of time. Please don't. So the truth here is really pretty simple. There is no real square root of negative 25. There is no number where if you multiply it by itself, you get it. Think about it. Is there any way to multiply a number by itself and get a negative number? A positive times a positive is a positive. A negative times a negative is a positive. No, it's a positive. So there's no way to multiply a real number times itself and end up with a negative. So for us in this class, if you ever end up with a situation like this, please don't mentally check out here yet. You would write this: no real solution. And you might say, well, why on earth do you put that word in there? I want to give you a full disclosure here. Like if you just said, there's no solution, there's no real solution. For us here in Algebra 1, that's where we would stop. In Algebra 2, you will learn ways to deal with square roots of negatives. And believe it or not, the way that you deal with that is to look at a whole branch of numbers called the imaginary numbers. I kid you not. I kid you not. Yeah, it's just a way of handling it. It doesn't mean that they exist on the real number line, because they don't. They exist on the imaginary number line. Yes, wonderful, wonderful word there. For us, we stop here and say there is no solution. There is no real solution. All right. Enjoy. Have a good rest of your day.
You too,
Thank you.
Mr. Anderson,
Thank you.
Yep, thank you. Have a good one.